At Dave Cooper Live, we connect the industry leaders in the architectural, engineering, and construction space with the people, the products, and the processes to help them build it better. What if one of the answers to building stronger structures and more energy efficient data centers has been growing out of the ground all along? When most people hear the words bamboo construction, they picture a tropical shelter, flooring, cabinetry, or a decorative finish. They probably do not picture structural beams and columns, commercial roof systems, curtain walls, server racks, or the infrastructure supporting artificial intelligence. But that is exactly where today's conversation is headed. LoüTeq is engineered bamboo into a high-performance structural material called SEB, Structural Engineered Bamboo. Today, we're going beyond the sustainability story. We are examining performance, fire, codes, manufacturing, constructability, cost, energy, and what this material must prove before it can scale. Joining us is Schüette, CEO and President of LoüTeq. But before we get into any or all of this, we got to give a few words out to our supporting members. Brought to you by GreyTech, developers of the complete light gauge steel and wood framing software for Revit StruxSoft. Off-site, modular, or prefabricated, StruxSoft Framer turns Revit into a powerful manufacturing tool, automating every step of the DFMA process from design to final delivery. StruxSoft doesn't just work with Revit, it transforms it. Jumpstart your designs at StruxSoftSolutions.com. LoüTeq Ltd. has a long history of innovation in cold form steel manufacturing and producing innovative precision roll forming technology for customers throughout the United States and the world. Check out their machine buyer's guide for off-site modular construction or fast build construction with light steel for framing. Go to their website, LoüTeqLtd.com. When the delivery can't fail, standard transportation isn't enough. Oversized, time-critical, high-risk, specialized transportation supports advanced projects nationwide. From data centers to the delivery and set of homes and offices. With more than 60 years of experience, we've transported over 60,000 projects, served more than 200 U.S. cities, and logged over 70 million miles. When failure isn't an option, choose the leader in specialized transportation. All right. Again, thank you to all of our supporting members. We can't do any or all of this without your support out there. So if you like what we do, make sure you check us out. Support us any way you like. All right. Couple housekeeping calls. We have the Exchange coming up. That's right. The Exchange by Dave Cooper Live. is going to be in Toronto in December at the Building Show in Toronto. This is 20,000 people attending this show. We have a stage on the main floor for 2 days, and we have an entire section just for offsite and technology. This show's for residential and commercial, and it has everything from concrete forms, cold form steel, modular, all the way through. It is a show you do not want to miss. And to top it all off, we are also Mass Timber Plus media partner. That's right. You can even see our logo up there in the left-hand corner. Super proud to be part of all of these different events, and we have so many more coming up that we want all of you to be aware of. So with that said, you're not here to talk about the shows we're going to. You're here to learn about what Luke is doing. So why don't we bring Luke onto the show? Luke, welcome to Dave Cooper Live, my friend. How are you?
Doing well. Thank you for having me.
So, Luke, before we get started in all this, I ask everybody the same question. We want to know everything about you. From the moment you were born to this very moment in time, do not leave out any of the good stuff from the hospital. We're going to have one of your family members on, and they're going to spill the beans. But either way, give us your elevator pitch, what you were doing prior to starting the new company and the bamboo from when you were born. And you're in St. Louis, right?
That's right. Yeah, it's an interesting story. You know, I grew up on a farm. My dad was an architect, and so I realized, quickly after I, graduated high school that was a pretty unique way to live. From baling hay and shoveling manure, going to job sites with my dad. He had his own practice since 1986, so there was a lot of running of blueprints, the old school with formaldehyde and all that in the house, and so it was an exciting way to grow up. And essentially, while I was in college studying architecture at Southern Illinois University, Carbondale, I took a missions trip, me and 11 guys, and we went down, and there was kind of a landslide that had taken place, where there was a little bit of over-harvesting of trees, and the root system, that was holding that mountain in place, it took about 10 years, and then all of that topsoil covered this town. And so it really hit me and impacted me, the way I was thinking about things. And while I was down there in Honduras, there was bamboo growing everywhere. And so obviously I was very inspired. And this bamboo species is quite large. It can be up to 8 inches, 6 to 8 inches in diameter, can grow 60 feet tall. And I was right in the middle of my structures courses with my professors, learning about engineered wood, structural composite lumber from glulam, PSL, LSL, all these different engineered wood products. And I thought to myself, what if we build upon this technology that we've been working on here in this country for about 150 years, and let's look at another lignocellulosic type of material to replace wood and be engineered together in a similar way. And so that's how it essentially started.
Say those technological terms again. What is it? What is the makeup?
It's high silica content, and so it's this measure, lignocellulosic. It's a measure between like the xylem and phloem tissue, and silica versus cellulose. And essentially, what's measured to determine like a wood species is, and its strength properties, is how much silica content is in it. If it's more of a cellulose-based fiber, then it's lower strength, has higher sugars, is more prone to fire, charring and burning. So when you have high silica content, your density goes up, and it directly impacts the structural performance and fire performance.
Love it. All right, so let's get into this, right, man? Like you're out, you're baling hay, you're working in architecture and building your entire life, and you have this idea. Where did bamboo come from? Like in your mind, like that you could say, hey, I could take bamboo and I could make it a structural feature.
Well, from that first trip, I was inspired, so I got some slats of bamboo. I went out to the barn over the summer and over Christmas break, and I made some prototypes out in the barn, glued them together with my dad's old wood clamps, and made some structural components. And then that following year, right after I graduated in 2003, I made some pretty nice prototypes, and I used an adhesive technology that you can get right off the shelf. And I had studied, and it turns out Gorilla Glue has some pretty nice structural performance. And the chemical makeup is very similar to structural composite lumber in the type of adhesives that are used commercially. And so I made these prototypes, and then I took them down to St. Louis actually and had them tested. And essentially we got these test results back, and they were quite good. And so then that's when I decided to present to the ASTM executive committee, where you have all of these big players, Weyerhaeuser, Louisiana Pacific, all multi-billion-dollar companies sitting at this table. And as a young kid right out of college, they gave me this amazing honor to be the task group of the DO 70203, which is this. It's a task group for adding what is structural engineered bamboo into the standard. Mm-hmm. And so that took some time, so from 2007, 2008, 2009, and then officially in 2012 was the big milestone where, with the help of some other great people, was able to add the structural engineered bamboo into the standard. So if you open up your International Code Council, that's the IBC, International Building Code, you'll see under ASTM 5456 that structural engineered bamboo is in the standard. So that was the first major milestone.
Yeah, no, that is awesome. And for those of you just joining, we are going to show you some videos. We're going to show you some slides. We're going to go through a couple of things here. So you'll be able to see all the products and everything that these that they are doing at LoüTeq. And I had to ask what LoüTeq meant, right? Earlier he said, well, we're in St. Louis and we're proud of that. So LoüTeq, and we're bringing technology from St. Louis. I love that. So let's get into this. Let's start from the beginning. How first do you harvest the bamboo and turn it into an engineered structural beam, column, or component with predictable properties?
If you would like, pull up that slideshow of the process, and I'll navigate. Essentially, what we have is a bamboo culm, and unlike a tree, it is pretty consistently, as it comes out of the ground, it's about the diameter that it's going to be. It does taper up towards the top of the plant a little bit, but the wall thickness, I'll go ahead here, I'm giving a little bit of a preview, but what we have is these slats that are milled and processed into, these are about 20 feet long by about 1.6 inches wide, by about 3/8 of an inch thick. And so those slats are very uniform because we harvest them out of the middle of the culm, and then we mill them into a shape on these shapers to create the raw material. And so yeah, that's where everything starts. And so we had to establish an entire supply chain to be able to do what we're doing at this point. It's been a long time, like I said. 2012, 2016 is when we first did our commercial structural application. So in order to do that, we had to establish an entire supply chain.
Right. And so it looks like you source this out of Colombia, South America. Is that correct?
That's one of the locations. We also have invested pretty heavily in a couple other locations, and there's locations in Mexico that are actually working out really well logistically, a little bit closer. There's pretty strong rail infrastructure coming in from Mexico into the Midwest. So we're working in that area as well.
Is there different types of bamboo or species of bamboo that you use, or is it any bamboo works for this?
This is extremely focused on species and moisture content, age, just like how we're seeing in the timber industry, where there's a difference between old growth southern yellow pine and in what you can get at a department store somewhere. There's more knots, it's less dense. And so very similarly, you have to use a mature species, mature plant. And these plants, very similar to trees, they continually produce these culms coming up out of the ground every year, but they need to be at least 8 years old to have the maturity as required. And then we look at species, and this is a major kind of point that I would like to focus on, and that is that the species out of Asia, There's several different species, and just so you know, there's over 1,500 different species. Just like timber, if I was going to tell you that I was going to build a house out of balsa wood, or oak, or Douglas fir, you would say, okay, yeah, we need to focus on this ideal species that has structural capacity. Bamboo is no different, and so we're looking at a species here that's called guadua. And guadua has been researched a ton. It was discovered about 200 years ago down in Latin America. It is one of the more prominent species. There are a few other species, but guadua, naturally growing in all of the Amazon and all through Central, South, all of Latin America, is the highest performance bamboo species in the world. And so this is a huge benefit, a very strong advantage that we have being in the Western Hemisphere, that the species that are coming out of Asia, like you mentioned, are mostly used for flooring and cabinetry and more like commodity type handicrafts. And the reason that that's the case is that entire industry is focused on the use of a species that's a lot less silica content, much lower strength. It's not actually suitable for structural applications.
So it's sourced and processed out of, sourced and processed into what we're seeing out of country. Then that gets shipped here. I'm assuming your manufacturing facility is in St. Louis?
Yes. So we are actually in the process of upgrading our facilities further. This that you're seeing here is an 87,000 square foot facility, and we're actually moving into a 226,000 square foot facility that is going to allow us to advance the process even further. But basically what you have is the process. These slats are launched into this press at about 400 feet per minute. They're stabilized with these brackets that you see, and then essentially it runs into the press. We do secondary lamination, and if you wanted to, we could hit that video just so that people can kind of get a foundation of the process that we're doing right here in the United States, all under one roof. And before you do that, though, I'd say, this is very different than a lot of other industries. If I said, hey, I'm going to start a steel manufacturing or steel fabrication company, I would be buying steel from wherever I can get it at whatever cost is the market will bear. We cannot do that. We have to do all the fabrication, all the processing to make it into these structural products. But before that ever happens, we have to produce the raw material. So that's why this whole process is so crucial.
Well, let me play this video so people can see it. And by the way, I mean, that product looks beautiful. I'd have it in my house. All right, here we go. Awesome. Love it. So, but that's the old factory. You're getting ready to move into a new factory.
That's right. So two things are happening. One of the main things is that the entire slat processing portion of our process is going to be all implemented in Latin America. So in Mexico and Colombia initially. And so what that does is it allows us to ship more volume of our raw material already pre-processed and already dried to about 9% moisture content. And so then when it arrives to our facility here in the United States in St. Louis, Missouri, we will be able to just load it right into the press. And so the next major advancement we're doing is that entire process is going to be more automated. The launching of the slats will all be just pulling right out of a large bundle of slats and going through the adhesive spreader process, and the slats will then lay up into the press all automatically. And the entire process all the way through to the secondary lamination where we're creating the large beams will all be automated. And so we're going to go from 600 cubic feet per day to 6,000 cubic feet per day, which is going to allow us to truly supply to some of these larger hyperscale type projects that we're going to discuss.
Where does structural engineered bamboo fit compared to steel, aluminum, glulam, mass timber, right? You know, part of the show, and you know what we were talking about, you know, prior to the show is, I mean, it's replacing steel. Is it really that strong?
Yeah, so that is one of the misconceptions. People like to say that it is technically stronger than steel, or they'll say it's, you know, green steel and all this. A lot of that is kind of disinformation coming from different parts of the world. The modular elasticity is about twice the strength of any timber. But steel obviously is very strong. There is one area where bamboo is technically stronger than steel, and that's the strength to weight ratio. Technically, that is one area where it is stronger because, as you know, steel is very heavy, and that's why you typically are creating shapes like H-beams, W-beams, joists, and tubed steel because it's so heavy. Whereas we're producing a solid square component, rectangular component to accommodate the structural load.
Got it. Got it. So with that said, then, you know, how does it perform? Does it perform like wood when it comes to like humidity and temperature? Does it perform like, you know, does it perform like steel with humidity and temperature?
Well, you're touching on one of the biggest advantages of the product in a little bit different market than what you would call the mass timber market. Mass timber is focusing on building the buildings, the floor plates, and various different structural applications, which is great. Our market is a little bit different in that we're going into areas that wood and most timber products cannot go into, and that is, for example, data centers and industrial components, mainly because of the thermal stability, the thermal coefficient of expansion and contraction. The materials are incredibly stable. In fact, even more stable than aluminum. As you know, aluminum is a conductor, and it does quite a bit of expansion and contraction. And so when you're utilizing our materials in this type of application, what you can avoid is fatigue from expansion and contraction, and also obviously thermal conductivity throughout the space. What people don't realize is when you're trying to cool a space down, you want the least amount of thermal conductivity within the frames and the structures within the building, because what happens is that heat leaches out through all the structural members of the framing and racking and hot air containment, and then it's more difficult for the HVAC system to pull that heat out.
Got it. Got it. So in IE, why, you know, like even with this picture of the data centers, it makes a lot of sense because, you know, a lot of sense because data centers make so much heat, right? But it can be so much more than just a rack, and I'll pull up your website and stuff here in a little bit. But before we hop into that, let's get into a little bit of the technical side of this. Which ASTM standards currently apply to your products?
So it's all per the structural composite lumber standards, and we reference ASTM. So ASTM 5456 has been the 100% focus for structural applications. And then I may have mentioned I chair this task group, which is within ASTM 5456 called the DO 70203, which was back in 2000, 2008, 2009, we were tasked with adding structural engineered bamboo to the standard. And so that process, as I said, took a few years, but if you open up your IBC, International Building Code, and turn to ASTM 5456, you'll see ever since 2012 when it was added, you'll see structural engineered bamboo integrated.
And with that, so it's in the building code now, so people can spec it out, architects can spec it out, engineers can spec it out, data centers can spec it out. You know, one of the things like wood and misconception is fire ratings. And this is something you kind of focused on heavily as well is, you know, is it fire resistant? Is it fireproof? Walk us through that.
So the term typically used within the building industry as well as the data center space, and that's that's really, if you simplify, the data center industry, it truly is just, it's the building industry, but yet it's more complex, because we're looking at the specifics of the building. So it gets more intense because we're dealing with all of this, expensive equipment. Obviously, it's generating a lot more heat than what humans do and other activities typically. So the building just needs to be significantly more complex, and that it needs to integrate materials that are fire resistant. Now, think about it, data centers, they're implementing plastics, there's wires that have coatings, and there's a lot of different materials that are combustible. So there are, suppression systems built into these data centers. So this material would be Class A, considered Class A. It's still combustible, but it's a low combustibility. In fact, the other thing that's measured is smoke density. So if something plastic starts burning, that's where a lot of people will then, have challenges, with other materials when they burn. The smoke density release when this material does eventually burn is a lot less. But the main thing I want to focus on is that there's a difference between fire performance when it relates to, like, for example, aluminum versus a material like this, structural engineered bamboo. And the reason is that the combustibility, that may happen at some point, but it will char first. And at these temperatures, we're talking 450 degrees, aluminum, which is considered non-combustible, will have already started to deform and or lose its structural capacity, as in melt. Maybe it doesn't actually catch on fire and burn like we see something burning, but if it melts, it's already failed and the damage has already occurred and the life safety has already been compromised. So this is why mass timber, heavy timber, and these buildings are considered to perform better than steel, better than aluminum in these types of conditions, because it will char and still maintain structural integrity long after a comparable steel or other beams would have already melted and collapsed. And so this is why timber, mass timber, and our products are considered a superior fire performance material.
So out of your products that you have, right? You have SEB, that's the terminology for the structural engineered bamboo. And then there's also ArchLam, correct?
Yeah, so ArchLam is the trade name for SEB. So that is the proprietary process that we create. If you want to pull up the main process slide deck, I'll kind of show how the material looks from the end condition. So essentially what we have is this, actually I went the wrong way, sorry about that. These are some of our projects and applications. But as we get into this process, so what we have is this radial laminated process, and this is what kind of differentiates the product. This is the proprietary process. So if you look over here to the left, you see what is a typical glulam beam. What we're doing is very similar to the glulam process, but we're creating these planks that are the radial laminated process. And what we do is we mill the inside and the outside of the slat to the same radius, and then we are engineering them together to create this structural composite. And so two things are happening. One is that we're optimizing the highest performance fiber, which is the outer portion of the column. We're also removing the lower strength fiber and isolating in on this high silica content, high strength fiber. And this applies to everything from strength to fire performance to density. It all is isolated in this structural composite.
Well, I'm going to transition then. So we got the technical side of this. We know it's structural. We know we can do large spans just like a glue lamp or mass timber. Data centers, right? Are you seeing data centers as one of the fastest growing segments for your product?
I mean, absolutely. So, it all began, we were contacted by a company called Vertiv. Actually, I'll go back a couple more slides here. Here we go. So these were the initial server racks that we built for Vertiv. And so these server racks, why did they approach us? Why did they select our material? Well, it's a couple reasons. One, they have all these companies have identified the challenge with cooling. Cooling, if whether you're looking politics or wherever you're looking, people all know that it takes a lot to keep these data centers cool. And people are concerned about water usage. These are irrelevant concerns. I get it. But they've come a long way. Even in the last 10 years, the technologies for cooling and all of that, more of a circulated system as opposed to pulling water from reservoirs. You're actually able to recirculate water and all that to keep things cool. But in conjunction with that, industries are looking for more thermally resistive materials. Technically, they're insulative materials. And so if you look at this shot, you see that the server racks, as they're bolted into these frames, they're able to be completely housed into a thermally resistive material, which prevents that heat from leaching throughout the entire frame. The other application, obviously, is what is called the hot air containment. And so that's this frame that goes up and around where the hot air is pulled out and removed from the servers themselves. And so the more that we can isolate in on the servers and removing the heat directly from the servers themselves, that equipment, the better and much more efficient that whole entire data center will function.
Yeah, and I have actually a thermal picture here. What are we looking at? This visual is best for everything, right? So
it is. So the shot that you're seeing up in the upper left is showing a similar system, if all made from aluminum and steel, which most of them are to date. And so what happens is that heat from the servers themselves leach out over the system. And so what this chart is doing, it's a comparative chart showing the differences between an SEB hot air containment and server racking system versus an all aluminum system. As we know, aluminum is one of the best conductors. It's a great quality, but it's also, in this application, it's a detriment, because as you're pulling the heat and leaching it throughout the space, that requires the HV system to use more cost, and you have to integrate more tonnage to keep the space cool. And so what we're also looking at on this is also the fatigue. When you have aluminum increasing and decreasing in temperature pretty heavily, you do get fatigue in the end conditions, and you can actually see failure over the course of time with those systems. So this is a direct analysis of how much energy can be saved if you're removing that thermal conductivity.
To me, it would. So I know we're talking about server racks here for data and all that, but wouldn't it make sense for these data companies to build the entire structure out of this? Because wouldn't an entire structure versus just the racks even take it to a whole nother level?
Well, perhaps. I mean, this is the thing, is that we want to embrace things that are new and things that are innovative, and that's been kind of the marketing behind mass timber. And in fact, Amazon, I believe, built an all mass timber data center, which is great. The thing is that we have to look back at the pragmatic process of how do we build in this country. And this is one of the things that we've developed, especially the last 60 years. We've really dialed in on how to build things very cost effectively. And I would say, as a realist, I would say, tilt up concrete slab, open web steel joists, it's going to be probably the most cost effective. It's going to be the most pragmatic. Whereas if you're going to try to reduce the heat and keep them cooler, then our materials would be more ideal in and around the racks themselves.
Is all these products kitted? Let's say I already have a data center and I want to replace my racks, or I'm building a new one and I want to put your racks in. Is this all like a kit of parts, so it's more of an assembly process than it is anything else? And can it be retrofitted into older data centers is, I think, the bigger question.
Well, that's a great question. We present ourselves as a material technology company, but because of my background, going to those job sites with my dad when I was 6, 7, 8 years old, all the way through going into architecture school, I have a real passion for how things are built. And so I would say even more so, the material technology has been figured out, since 2007, essentially till now. And now our company focus, I would say much more so than the material technology, is how do we kit these structures, whether it's a building, a solar structure, or a server rack. How do we pre-kit it so that when it goes on site, it can install and assemble very quickly. As opposed to being built, it's essentially assembled. And so this is one of our focuses as a company, is to really dial in on how do we pre-design everything and pre-kit as much as possible within our shop.
So the physical properties of all this, is interesting, but I would imagine building owners, data center owners ultimately want to understand the measurable operational and financial impact to them. Have you guys done any analysis models, with all the heating and cooling and the energy transfer and the savings?
We have, and if you don't mind pulling up that white paper, it's the an
I got a lot of them here.
analysis.
Is it
Yeah,
this
so
one?
it's
Oh,
no, not that one. The other one. Yes, this is it, I believe. Let me
mhm.
go back a couple slides here. Oh, that's the fire performance. So it's the data center. This is it right here. Cooling costs and savings analysis. So what we're looking at here, and I would encourage everyone to go to our website. You can download all of this on the data center section portion of the website. Essentially, what this white paper is showing is if you take, for example, and we're utilizing a standard build out of a 10 megawatt data center, and the typical cooling cost required with conventional technology, conventional framing, such as aluminum and steel, you're going to be spending X amount, millions of dollars in cooling costs per year. And so what this shows is a savings, dependent upon the level of implementation, of between 18 to 39, 38, 39% in cooling savings, which even if it was 5%, this is millions of dollars in cooling costs. And so this is a really in-depth white paper that shows the full analysis of how much a typical data center can save on cooling costs. And so I would highly recommend, as you mentioned, a lot of these older data centers are utilizing older technology. They need to go in with new servers and new equipment anyway. And we would really embrace those types of renovations where you can take older buildings, older data centers, and retrofit them with our material technology to try to help them be more efficient. And that goes in hand with the new builds. As you know, many of them are being proposed where these newer technologies are being implemented, better cooling systems and all that. But reaching back and fixing some of these that are 20, 30 years old, that's what people don't realize, I think, even in the overall dialogue, is that we've had a lot of large data centers in this country for more than 20 years. And so to go back and maybe make some updates to those, I think would be a good plan.
Why and this is just something I didn't ask earlier. Why use bamboo versus glulam or mass timber?
Yeah, it comes really down to the structural performance and the stability. You maybe have seen timber when it's heated, and specifically you would do a comparison perhaps to like a desert condition. Timber is a great material for buildings, can move around a little bit more than a lot of other materials. And so I would say that's why in data centers specifically, especially these server racks, it's not going to perform as well. So for example, you'll see that one of our other major markets is curtain wall and glass systems. Now, timber, and there are certain species, especially in Europe, that are implemented into hybrid glass systems to help with the thermal performance. But what we're able to offer is thermal performance alongside dimensional stability and uniformity and consistency. Whereas knots, voids, checks, and things like that, if you want to click on the glass section up there at the top, you'll see, that's one of our key markets. And essentially, our data center market is an outgrowth from this. We learned so much when we launched our hybrid glass solutions about the thermal performance, the stability. In fact, there are companies, global companies, that will use our material but still not use timber. And so that's kind of a major differentiator. You can understand that maybe they will not use timber because it's too much of a liability, whereas they will use our material because of the stability and performance.
Sounds like all the work's been done on this. Now it's just a matter of getting it out to the market. So here I am. I'm a developer that wants to build a large building, but I'm also in technology, and I'd like to have a data center as well for my building, right? Because that's the new thing. Everybody having their own little data centers. How do we work together, Luke? I call you. How do I get your product? How does this work? What's distribution look like? I mean, there's so many questions here.
Well, typically it does need to kind of come from the top down. It needs to be a developer, someone who is looking at the numbers. You know, the whole pitch towards sustainability is fine. Yes, the materials are rapidly renewable and they're considered like biophilic and sustainable and all that. But our company is focused on the performance. And so if you're a developer, the first thing I would want to talk about is what are your operating costs? What's your life cycle analysis to run this data center? How much are the cooling costs? And very quickly, we'd be able to justify the implementation of our materials, even if they are slightly more expensive, perhaps, than some other materials. But in most cases, you know, the price of these server racks are pretty expensive. I was blown away when we were doing our prototyping with LoüTeq, for example, that we were consistently well below the cost of steel and aluminum within these data centers applications, because you know there's a lot of demand for the product. And so what we're adding is another material technology, maybe to pull a little bit of pressure off of the steel and aluminum industry that's going into data centers, and maybe even level the playing field out, because as you know, as you can imagine, a lot of that material is probably coming from overseas, drop shipped into the United States, and with tariffs and things like that, to implement a US produced product logistically based right here in the middle of the country, we can potentially come in more cost effectively.
So what, in your mind, what is the biggest obstacle to widespread adoption of SEB?
Yeah, I mean, I would say, you know, it's going to take a couple ambitious developers that really look at the numbers and decide, hey, we want to take a chance with this. I understand that it's a little different. It feels new, but as you heard, you know, this has been in development and developed for a long time. You know, how long does it take for a new material to kind of position itself? Well, engineered wood, we've been engineering wood for about 150 years. These products, you know, we did the first commercial structural application for an airport roof back in 2016. So we just celebrated 10 years of that project being installed. Another project down in Miami, Florida, where we did 80,000 square feet of ceiling systems, went through Hurricane Irma with no damage. And so we're proud of these milestones and the technology, you know, its advancement to be able to look at some of these markets. But this is what you said. A lot of the technical work has been done. We've focused in on this foundation building of the certifications, the testing, the standardization, to where engineers can feel confident in specifying the material. And so that's where, you know, we would want to provide all that information so that the engineers of record can make those choices.
Luke, what didn't I cover on this? Is there anything that we missed?
Well, I would say you covered everything wonderfully, but you know it takes a little bit of you know, people to step back. You know, think about the glass industry. You know, we've been implementing all aluminum glass for 60 years. Even though everyone knows, you go into some of these spaces, you see frost build up on a cold day on the inside of the glass, because you see the aluminum conducting all the cold and or the heat out of the building, which causes the frost buildup. Well, it's a common known fact that, you know, a hybrid solution can really save in costs. And so to really just not keep respecing the same thing and step back and say, hey, right here in the United States, there's these companies that are doing some cool things, implementing material technologies that can actually save costs. And maybe it takes a little bit longer to do it, but to take the time and specify some of these materials that can really have long-term benefit.
Here's what I like about it, Luke, and I'm keeping your website up there so people can write it down and check it out. You already have all your standards. You're already in the building codes. So this isn't an idea. This is actually a product that can be used immediately, correct?
That's absolutely correct. And the other thing too is that was where the entire company started, was in the architectural building products industry. We were contacted by Amazon Robotics, by Vertiv. They were all seeking out these material technologies. And this has been also years ago as well, where all this prototyping, the collaborative white papers were created to prove out the relative, you know, absolute integration possibility for the material. And so this is, like you said, it's ready to be implemented.
Luke, I appreciate you joining us today on the show, man. This has been great, and I hope people really take a serious look at everything you guys are doing and what you build. It's no small operation. You have proof of concept, you have everything. And it seems like it just makes a lot of sense for people to really take a good, hard, strong look at this. So appreciate you being on the show today.
Really appreciate the opportunity. Thank you so much, Dave.
Absolutely. Don't go anywhere. I'll come right back to you here in just a moment. So, all right, everybody, listen, today's conversation really does show the future of construction is about finding the right materials for the right applications and validating its performance with credible data. Luke, thank you for joining us and sharing the LoüTeq story. I love it. LoüTeq from St. Louis, Missouri. I love it. I love it. If you value independent conversation with the people transforming the built environment, you can support the platform and join our global executive community at membership.davecooper.live. We will see you on the show. I guess it's going to be Monday. I can't believe it's Wednesday. It's hump day. Know what that means? Tell you what it means. That means you still have 2.5 days to get out there and keep building it better. I'm Dave Cooper. I hope you enjoyed this. Thanks for watching. Bye now. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you. And as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.